Now let's test if this function is an even function, if it's symmetric around a line on the y-axis. So perhaps something like that, right? And to test it, well, we know that in the previous example, we found that the max occurs when a is equal to 4. And in order to test, we need to show that, f of a minus x is equal to what? F of a plus x. And x is just some number, just some constant number. So if this function is symmetric, it should be the case that negative x, well, let's try this. Let x, these x's, be equal to 1. Then f of 4 minus 1 should be f of 4 plus 1. And let's try that. So we're going to have negative 4 squared. Made a mistake. Not 4. What do I want to put in here? I want to put 3 in here. And I want plus 8 times 3. That gives me negative 9 plus 24. What is this equal to? This is f3. Now f5 is equal to negative 5 squared plus 8 times 5. And that gives me negative 25 plus 40. If I go up here and finish this, I get 15. And down here, I get 15. And so if we are here, or if we are here on the diagram, and I dot my way over to the y-axis, we're going to be at 15. And remember, the max occurs at f of 4, which was equal to 16. But that's really just an aside, because if I take this and I move it over here, we can see that f of 3 is equal to f of 5. So the function is symmetric around the y-axis. The function is a mirror image. This part of the axis is a mirror image of this side of, I shouldn't say around, maybe I shouldn't say the y-axis, I should say around x equals 4. A point, this line around, symmetric around this line. And what's the equation of that line? Well, it's x equals 4. You might have remembered there was a test question on ALEX that was asking you the equation for a vertical line, and it's one where we have x is equal to a number. Y doesn't come into it. X is equal to 4 for any value of y. There are a few ways that I could go about answering this question, so I want to find the max or min, and I want to exploit symmetry. One thing I could do is maybe what I'll do is find the x-axis intercepts. And to do that, I'm going to set y equal to 0. So I get 0 is equal to negative x squared plus 8x. And when I do that, I want to find, well, I'll say find x values that satisfy this thing, this equality. And I can see that I've got x is equal to 0. That would satisfy. What else could I do? Well, I could rewrite this as x squared is equal to 8x. I could divide both sides by x. And I get x is equal to 8. Notice I'm dividing by x. I'm not taking the square root. And so I've just got one value here. Now I could draw these points just along the grid line here. And it's very nice. One way I could exploit symmetry is I know that if this is an even function, the max or the min occurs at the midpoint of x and negative x that have the same y value. And so I've got 8 and I've got 0, and if I go 1, 2, 3, 4, 1, 2, 3, 4, I can find the max right here, which is going to happen at 4. Here's a question for you. Go ahead and determine if this is an even function. So if we have f of a plus x is equal to f of a minus x, then in this case, since the function is symmetric, or we're testing whether it's symmetric around the y-axis, so we can let a be equal to 0. And then we can test whether f of x is equal to f of negative x. So we got this function up here. How about we let x be equal to 2? And so f2 gives us negative 3 2 cubed plus 8 times 2. And that's going to give us negative 3, 8 times 8 times, or sorry, 2 times 2 times 2 is equal to 8. Plus 16, and it looks like we've got negative 8 here. And I'm just going to, oops, see if we can just move that, or just move it over a little bit. And now I'll look at f negative 2, which is equal to negative 3, negative 2 cubed plus 8 times negative 2. And we're going to have negative 3 times negative 8 minus 16. And that's going to give us 24 minus 16 is equal to 8. And so, given this, is it an even function? No. It is not an even function. Because f of 2 was not equal to f of negative 2. And just to be clear, around the y-axis. Let me clear that up, try that again. They're not equal to each other. In fact, this thing is what? This is actually an odd function. So if we tested it to see whether it was an odd function, whether it's symmetric around the x-axis, we would find that it indeed was symmetric around the x-axis. But that's not what the question was asking us, and that's not something I'm asking you to do. So we don't know the function or the x-axis coordinates, but we know this is a symmetric function. And I should say specifically an even function. And so one of the properties I showed you is that y is the same value for x equals 0 and x equals 6. But 0 and 6. So the max min must occur at the midpoint, which is going to be, in this case, it's going to be 6 minus 0 divided by 2. It's equal to 3. So that's it on symmetry. I just focused on the even functions. I want you to focus on the even functions. Very simple, very straightforward. And hopefully you'll find it helpful in the future.